Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the year-end summative. It's question number 6. Question 6 is a triangle question. It says draw and solve each triangle. Round your answers to the nearest tenth. So there's a part A and a part B. So let's look at part A to begin with. So when I start a question like this, I always start by wanting to visualize my triangle. So the first triangle I draw, I never intend to make it accurate in terms of um, sizes or angles. I just want to make sure that I get my references right in terms of where all the vertices are with regards to each other. So I'm just going to draw using technology just any old triangle. And be careful when you do something like this that you're not, this triangle looks really nice and it almost looks isosceles, but that's not my intent. My intent is just to get a triangle on the paper so I can label my vertices and I can start to write some numbers on it so I know what's going on. So I'm told that BC is 25 units. I'm told that AC is 28 units and angle C is 76 degrees. So I need to know that information because that helps me figure out what strategy or what tools I need to help me finish this triangle. So I'm going to need to find at some point angle A, angle B, and this missing side, and that missing side would be little c or side AB to stick to the nomenclature or the way that things are labeled in the question. So how can I start? Well, it's not a right angle triangle, so I can't use sine, cosine, or tangent ratios. Um, the next option is to use the sine law, so I've put it over here. So there's the non-trig thing. So there's the cosine law and the sine law. Um, and always, I try to use the sine law first if I can. But in order to use the sine law, I need one of these pairs. So I need sine B over B or sine C over C or whatever. I need to know both an angle and its opposite side. And in this triangle, I don't have that. I know side A, but not angle A. I know side B, but not angle B. I know angle C, but not side C. So I can't use the sine law. So this is a cosine law question. So the cosine law, when you're using the cosine law, to be careful when you're using it, you need to make sure that the side that goes isolated on the left matches the angle that you're using in the cosine part of that question. So in this triangle, because I know angle C, I'll be finding side C. So it's kind of nice. I can use the cosine law without having to put in any new letters. I can use it directly. So c squared equals a squared plus b squared minus 2abc cos c. So let's go ahead and use that. So c squared equals a squared plus b squared minus 2 times a, b, and then cosine angle c. And again, you'll notice if you've watched my other videos that this is how I use formulas. I write them first with blank brackets, and then I go back and I substitute in. It helps me make sure that I'm not substituting wrong or writing the equation wrong because I'm only focused on one thing at a time. So now I need side A and side B, side A and side B, and then the angle that corresponds to side C is 76 degrees. So now I just have to be careful with order of operations and make sure that I calculate this correctly. So 25 squared, and I'm going to go through kind of carefully step by step in this question just to make sure that, if you're generally understanding this material, that you're not making the mistakes in the calculation. So I'm doing the exponents here, so 25 squared and then 28 squared, and then it's going to be subtract. Now all of this stuff is multiplied together, so I'm going to multiply 2 times 25 times 28. That gives me 1400. And I'm going to calculate cosine of 76, making sure I'm in the proper mode in my calculator. So cosine 76 is, keeping 4 decimals, 0.2419. Oops, kind of off the page there. So the biggest mistake I see students making is an order of operations that's about to happen. And that is that they see this plus this and a subtraction sign, but they forget that this is a multiplication situation here. It's all of this stuff was multiplied together, and it's still supposed to be multiplied together. So I'm not ready to do my addition and subtraction until I've done that multiplication step. So the whole thing is going to be minus 338.69. So 338.69. Now I can do those add and subtracts. So 625 plus 784 minus 338.69. And I get that c squared is 1070.31. And then, of course, I don't want c squared, I want c, so I take the square root, and I get 32.7. So now I know that the length of this side is 32.7. So now that I know the length of side C, I now have one pair of angle with opposite side, which means I can now start to use the sine law. So you only ever use the cosine law once in a question, and then you get to use the sine law. So to set up the sine law, the pair that I know is sine C over side C. So there's the pair that I know. And so what I'm looking for is I need to know angle A, but I do know side A. And I also need to know angle B, and I do know side B. So you'll notice that when I set up the sine law, I put the pair that I know in the middle, and that's just because I like to be able to sort of look at this as one equation, do the math on that one equation. Ooh, sorry, I forgot that that did that. Um, I meant to use here. Let's do the other purpose here. There, that's better. So I like to use this partnership and solve for one of them, and then it's set up so I don't have to rewrite anything. There's the other partnership, and I can solve separately for that one. So let's go ahead and do that math. So I'll start with what's on the left. I don't want to use that magic pen again. That's what it's called. It's called the magic pen. Isn't it fancy? Okay, so how am I going to do this math? Well, first of all, let me actually just separate this out, and I think this will work. Oh, technology, copy, and then I'm going to grab it and paste it. Oh, life is good, right? All right, so this is what I'm going to solve for. So how do I find this? Well, because I have a proportion here, I can cross multiply. So I'm going to cross multiply. I'll do sine A times 32.7. So now there's nothing to do there. That's just 32.7 times sine A. And then the other crossways will be 25 times sine 76. And then to isolate sine A, which is what I need to do, I need to divide both sides by 32.7. So divide by 32.7. And that leaves me with just sine A equals all of this. And I like to do this before I access my calculator, because this way, you can type it into your calculator a little more directly. You've done one set of thinking before you do a calculation type thinking. So that's what I have to type in. So order of operations, I'll do sine 76 equals times 25 divided by 32.7, and then I'll take the 4 decimal places, round it correctly. So I know that sine A is equal to 0.7418. And then to solve for A, I need to inverse sign that decimal. So in my calculator, I get 47.9 degrees. Okay, so I know that angle A is 47.9 degrees, and now I need to find angle B. Now, I could just use the rule that the angles add to 180, but I actually prefer to save that for a check of my math. So I'm going to use the sine law again, and this time I'm going to solve for B. So let me grab what I need. Close enough. And let's go solve for angle B. Exactly the same idea, just obviously different numbers. Okay, so here it is. I don't want that equal sign shouldn't be there. Okay, so here's the proportion that will help me solve for sine B. And again, I'm going to do the same sort of math, which is it's a proper proportion, so I'm going to cross multiply. So when I do this times this, I'm going to get 28 times sine 76. And the other crossways, I'm going to get 32.7 times sine B. And then to isolate sine B, I need to divide by 32.7. So divide by 32.7. And that'll leave me with an expression for sine B. So it's 28 times sine 76 over 32.7. And now I can type that into my calculator. So sine 76 equals times 28 divided by 32.7. And I get a decimal value of 0.8308. And now I just have to inverse sine that, and I'll know what angle B is. So inverse sine my calculator tells me the answer is 56.2. So if we go back to the diagram, this is 56.2. And this is why I like to use that 180 rule as a check. If I quickly add the three angles in my triangle, if I get 180 or reasonably close, because there is some rounding involved, if it looks like I'm at about 180, and I'm at 180.1, then I'm pretty confident that I did my math right. Okay, so there's the answer to one. Now, the question did also say to draw the triangle, so I'm not sure if your teacher wanted you to draw a reasonably accurate diagram or if this sort of ugly sketch is good enough. So just remember that if your teacher does want you to draw a reasonable diagram, you're not supposed to use protractors. No one's asking you to actually measure out perfectly what it looks like. But maybe, this 47.9 and 76, it's not the best diagram, so you might want to adjust it if you're worried about that. So let's go on to part B. Again, draw and solve each triangle around your answers. So let's start with a triangle. And again, I'm not trying to make it accurate. I just want to see a triangle so I can label and figure out what information I have and what tools I can use to solve. So I have triangle STU. Well, I hate using the letter S because it looks so much like a 5. So I will do my best to make it S-like, but it's tough with the tool that I'm using on this tablet. So I know that side S is 8.3. I know that side T is 9.1, and I know that side U is 10.4. So I know all the sides, which means I'm going to have to find all of the angles. So obviously there's no right angle, so I can't use sine, cosine, or tangent ratios. I can't use the sine law because I clearly don't know one partnership between an angle and the opposite side, which means I have to use the cosine law. But the cosine law is nicely set up to solve for a side if you know its opposite angle. But in this case, I don't know any of the angles. So I get to pick which angle I want, and then we'll rearrange the cosine law appropriately. So I'm going to pick angle T because I hate writing S's, and a T is pretty hard to mess up when I write it, although you'd be surprised. So this is what the cosine law would look like where I'm interested most in the letter T. So I'll rewrite the cosine law using the letters appropriate to the question. So again, making sure that the side over here matches the angle over here. Now, because what I'm actually looking for is the angle, I need to isolate the trig expression. So my goal now, before I do any substitution, I'm going to isolate the cosine t expression. And then I'll substitute in. You can substitute in first. I just find that this way I personally make fewer mistakes. So I'm going to get rid of s squared plus u squared because they're just both added or subtracted to this cosine expression. So t squared minus s squared minus u squared will equal negative 2su cosine t. And again, I'm going to put that yellow box around the cosine t because that's my goal, right, is to isolate that. So it's good to focus on it. So now what I have is the yellow box, my goal, that thing that I want to isolate, is multiplied by negative 2 SU. So to get rid of multiply, we divide. So I'm going to divide both sides by negative 2 SU. So negative 2 SU. And that will give me, so over here, I'm just going to rewrite what I have. And what I'm left with on the right is just the cosine expression. And that's what I want, because if I can find cosine t in one calculator button, I'll know what t is. So now I'm ready to substitute into this equation. So t squared minus s squared minus u squared divided by negative 2su. All of that will equal cosine t. And again, just like in the first part of this video, I always write my equations first, and then I substitute into the brackets. So let's see. I'll just read this off my piece of paper because the screen is too high. So t is 9.1. S is 8.3. And u is 10.4. And now I just have some calculating to do. So on the top, 9.1 squared minus 8.3 squared minus 10.4 squared. That gives me, on the top in the numerator, negative 94.24. And in the denominator, I'll do negative 2 times 8.3 times 10.4. And that gives me negative 172.64. And so if I now do that division, so 94.24 divided by 172.64. You'll notice I didn't say the negatives because I know that two negatives will just cancel each other out. So why waste two extra buttons on my calculator? So I get point, oh, my pen switched colors. That's all right. And then rounding correctly to 4 decimal places, this is what I get. So 0.5459, and now to find t, I just need to inverse cosine that. Wow, my pen is just going crazy right now. That makes it exciting, right? So when I inverse cosine that, I get 56.9. So angle t is 56.9. I really don't know what's going on with the color changes. So now I know angle t. It's 56.9, and that would go right here. And now that I know one of the angles along with its opposite side, now I can use the sine law to find the rest of the sides. Sorry, the rest of the angles. So to set up the sine law correctly, the one that I know is t, so I put that in the middle, sine t over t. And then sine s over s and sine u over u. Okay, so just two separate little proportions to solve for. So sine s over s, and side s was 8.3, equals sine t, which I've just discovered is 56.9, over side t, which is 9.1. So to solve for this, again, it's a perfect proportion, so I'll cross multiply. 9.1 times sine s equals 8.3 times sine 56.9. And then divide both sides by 9.1 to isolate the trig statement. So sine s is 8.3 times sine 56.9 divided by 9.1, and now I can go ahead and type that into my calculator. So sine 56.9, oops, sine 56.9 equals times 8.3 divided by 9.1. I get 0.7641. So sine s is 0.7641. So if I inverse sine that, I will know what angle s is. So angle s is 49.8 degrees. And now I'll do basically the same math, and this time I will take this in order to solve for u. So let's just grab a different color to differentiate it. So now I'm going to have sine t over t is sine u over u. And again, it's a perfect proportion, so I cross multiply. So 10.4 times 56 point, sine 56.9. So 10.4 times sine 56.9 is equal to 9.1 times sine u. Divide both sides by 9.1. So 10.4 times sine 56.9 divided by 9.1 is sine u. Type all that into my calculator. Sine 56.9 equals times 10.4 divided by 9.1. And if I round correctly to 4 decimals, I get 0.9574. That's the value of sine u. So to find u, I just need to inverse sine that. 0.9574 equals u. So angle u is 73.2 degrees. 73.2 degrees. And again, so u was 73.2, and s, let me just remind myself, was 49.8. And now I'm going to add those three angles together to check my math and see if I get reasonably close to 180 degrees. Because if I did, then I'm pretty confident in my math. Yep, I get 179.9, so I'm pretty happy. I think I did my math right. It's not the best, most representative diagram, but it's, it could be worse. So I hope that was helpful, and I'll see you in another video.